talking about important stuff. Yeah. So, log cosines. Do you think you did it or not?
We did it.
I'm pretty sure we did it.
Pretty sure you did it? Okay. So if I throw a formula up there, it'll maybe look familiar. Okay. No, it's really long. It's only got one trig function in it.
There's an angle.
Okay, there is one angle in it. Log cosines, obviously, log sines used all those angle-related, log sines use lots of angles, so log cosines is better when you have lots of sides. So log cosines is going to work for you when you have side angle side and side side side. So if you know lots of sides, you're going to think, oh, log cosines is probably my better option. If it starts with an S, you use log cosines. If it starts with an A, you use log sines.
Is there a log tangent?
There actually is. I personally never learned it or never used it. But there is one.
We have to learn it.
No, we will not be learning it. Okay, this formula, consequently, it's actually developed off it's off the Pythagorean theorem, and we turn the coordinates and we're doing distance formula, but we're doing coordinates with trig functions in it. But notice if you're solving for side A, the other two sides are of course B and C, but then there's this extra piece added on. It'll be the same two letters. If you have B and C here, you'll have B and C there. Cosine of angle A. The angle goes with the side you're trying to find. Okay, so consequently, tell me how this would change if I was solving for side B.
B minus A squared.
These would have to be A squared and C squared. It's the same exact formula, you just switch the letters. So that would have to be A and C then. It's the same two sides you have here. And it has to be cosine of B then, since you're solving for side B. And then consequently, if you're doing C squared, it's A squared plus B squared, 2AB cosine C. So it's actually, well, it's kind of a long formula. It really isn't that hard to remember.
How is that possible, though, with the Pythagorean theorem?
Okay, there is a page and a half proof of this in your book. I do not have time to do this proof. I'm sorry. Yeah. And it's actually mostly based off of, it's doing distance formula. And you end up foiling something, which gets you the A, B, you foil things together. That's the middle term of your foiling. So that's where it actually all comes from. Because you have to square a quantity, and you square a quantity, you end up with that in the middle, and it gets a little interesting. Okay, I think log cosines is pretty easy to use. If I give you A, B, C, and I tell you, you know side B here is 5.8, you got an angle of 35 degrees, and you got a side of 3.7, hopefully you look at that and go, hey, dude, that's side angle side. And so therefore, I can use log cosines. Now, what's the only thing you can solve for, though?
Side C.
Side C, yeah. If you know these two, particularly if this is the only angle you know, then you have to find its opposite side. You have no choice. So even if you were asked to find something else first, you would have to go find, in this case, side C first. So all we're going to do then is C squared equals, and, yeah, so 3.7 squared, 5.8 squared, you know you're going to just use the two sides you've got, minus 2 times what? Yeah, those same two numbers, 3.7 and 5.8, and cosine of 35. Okay. You can literally punch that entire thing in your calculator in one step. You don't need to work out each piece separately. Just run the whole smear into your calculator at once. But realize when you do that, yes, you're going to get something rounded off. It's about 12.17, but that's C squared. So once you get that answer, you're going to have to square root it to get down to side C.
So it would be a plus or minus?
Technically it's plus or minus, but we're finding a length of triangle, so it's got to be positive. So there will not be plus or minus answers.
12.17.
Yeah, and square root of that. And since they were doing one decimal place here, two significant digits, we would just round it off to the same and say it's 3.5. The side angle side problems are really easy. We like side angle side problems.
And find the other angles using log signs.
Okay. Then, I know I said, I didn't get it said if I get to the word problems, they're wicked hard. Okay? There's no way
I remember the word.
I'm not going to get to word problems today, which means next class is word problem heaven. Okay? Now, first of all, two things I need to make a point about. Once you find this side, and you know this side is 3.5, do you have to keep doing law of cosines to find the rest?
Can't you do law of signs then?
Now you know a pair, you can go back to doing law of sines. So you only ever have to do law of cosines one time. And then you can always go back to using law of sines after that point.
What would you do if you had side, side, side? Would you be able to find
solve for an
any
angle.
Yeah, we'll solve for the angle. We'll get to one of those in a sec. But unfortunately, I have to show you one of the wrinkles of law of cosines here. And I was never taught this, didn't discover it until I was teaching several years when we hit this problem and the answers wouldn't come out right. Couldn't figure out what was going on because we'd done the math perfectly fine. And turns out there's a rare instance that it happens on some law of cosines problems. It's not that frequent. And you have to, well, I'll just got to talk you through here a second. What would you all think you should solve for next?
You can solve for angle A or B.
You can solve for A or B. Doesn't matter which one you do next.
Probably.
It shouldn't. You would think it shouldn't matter. I could do A or B. Okay, well here's the wrinkle. This angle is 35. So therefore, isn't there room for one of those to be an obtuse angle, possibly? Yeah. Okay, and if I do log signs and I do inverse sine when I solve for an angle, is my calculator ever going to give me an obtuse angle answer? Is it ever going to give me an answer over 90? No, it is not. Okay, so we have to go back to geometry here. Okay, if there is an obtuse angle, which one will it be? Does it have? Why does it have to be B? Yeah. If there was an obtuse angle in here, wouldn't it have to be opposite angle B?
Yeah.
So therefore, if it has to be opposite angle B, then I don't want to solve for that one next. Because if I do log signs on this, it's not going to give me an obtuse answer. If it turns out B really is an obtuse angle, I need to go solve for the smallest one next. Because then I can subtract these two and find out how big B is. So you must always solve for the smallest remaining angle that's going to be left.
But you don't know which one it is.
You do. 3.7. We know from geometry the smaller angle is opposite the smaller side.
Sorry, I'm like you and sophomore. Leave me alone. I know. I'll find that.
So I'm sure this is a journal question. After the law of cosines, you must So that's crucial. Once you've done a law of cosines, you have to go find whatever's going to be the smallest angle that comes next. You can't go find the biggest one, and that's really easy to forget to do. So, and I actually, if I have a moment, I'll prove that to you. But here, all right. So, in our case, we said do I want to solve for B then or A? The smallest angle is going to be A, so I would need to set up a law of sines to solve for A. So sine of 3.7 or sine of A is to 3.7, and then the pair I now know is 35 and the 3.5 we just found. Okay, how are you going to solve for this? So what are you going to have to punch in your calculator? I don't know this decimal. Divided by 3.5, and you're going to get some decimal. 0 point something or other. Thank you. You have to do, you're finding angles. So every one of these kinds, you're going to do inverse sine of whatever, 0 point whatever you get. I don't have that decimal written down. Okay. If you do inverse sine, you are going to get 37 degrees. And what, did I say what side I wanted to find in the first place? Or I didn't say it. We were finding anything. Okay. So now, did we end up with B an obtuse angle or not? How do you know?
Because they add up to less than 1.
Yeah, if A is 37, C they gave us was 35, so that means angle B, that only adds up to 72 degrees. So angle B is 108. Okay, if you did law of sines to solve for angle B, if you had done law of sines to solve for angle B, you would have gotten an answer of 72 degrees. Because your calculator would have spit out a first quadrant answer. It would give you the second quadrant answer. Yeah, they would have to. It's the same old thing. Your calculator is going to spit out 72. You don't know, are you in the first quadrant or are you in the second quadrant with 72? So yeah, it's always going to be the supplementary angle. You know that much, but yeah. Oh. Yeah, it would be. Yeah, it's going to be. Yeah, it is. Yep, it's going to be that way. So, but you're not going to know, if you just did law of sines to solve for B, you were going to get 72 as an answer. You're not going to get 108. You have to find the smallest angle next. That's what, I had to dig through several trig books before I could ever find an explanation of it. It's kind of, it doesn't happen that frequently, but it is something to be concerned about.
So, in other words, you should always say.
No matter what, find the smallest angle next, and you'll be safe.
Are you notifying the angle A and C, and look at the sides of A and C? Like, how the decimals the same thing?
Oh, that's just a fluke. That was a lucky sort of happened. Okay, let me show you how you do a side one. I could be using my drawing tools here. Oh, you didn't go. Sure. I hit that. Draw me. Oh, I didn't want that one. Sorry, wrong one. That is a circle. You're right, because that's not the one I wanted. I want the auto draw. That one. Take it, dude. Well, maybe. There we go. Okay, so obviously I didn't draw this to scale. You know all three sides this time. And I'm going to tell you I want to find angle C. We could actually find any angle here. It doesn't make a difference. When they've given you all three sides, any one of them works. Okay, so since I want to solve for angle C, what letter has to be on this side of the law cosine? That has to be side C if I want to solve for angle C. And so it's going to be the version with A's and B's in it. And then cosine of C. Okay. So in this case, yes, we're going to have to do a little bit of algebra. What's C here? C is 44 squared. You don't need to work those out. You don't need to square those by hand. Don't do it. Not worth your time and trouble. A is 56 squared. B is 37 squared. So I'd have 2 times 56 times 37. Same numbers. And cosine of angle C. Now, here's where the only issue I have with people solving these is we break the order of operations. I have people who want to put all of this in their calculator they want to do 56 squared plus 37 squared minus 2 times 56 times 37, turn that into one number, cosine. This is all multiplied, but these two are added and subtracted. So how do you solve for, you got to solve for cosine. You got to get cosine by itself. These numbers in front of cosine are going to
all those numbers together, can't
You
you?
could. If you want to multiply them together, it's fine. I'm going to tell you, when I do it, I just go, oh, these two need to get subtracted over, so I subtract them over. I don't bother to square them out. I can type it in my calculator just like that. I know I'm going to then divide the numbers in front of cosine over, So I just divide by -2 times 56 times 37. If you want to work out all the numbers, if that makes more sense to you, you can work them out, but if you don't, you can just subtract them over like that, put that whole thing in your calculator and get the decimal value. You are going to, yes, first you got to get the decimal, which I do know this one is .6199. First you got to get the decimal, and then yes, you inverse cosine it to get the actual angle.
Why is 2 negative down there?
Because that was a minus. So I'm dividing -2.
Okay.
All of this is times cosine, so I have to divide it to the other side. Yeah, I know. But I got it. Well, I just want to finish this problem. So then, yes, to get your answer, you will inverse cosine that .6199 to get your actual angle. 52, it should be. Yeah, I want to say, are you radiating degree?
Yeah, I think I am. We'll find out.
I'm sorry, what?
I've kind of like printing out wrong answers all day, so.
To convert to radians?
No, I mean degrees.
Oh, well, it has to be between 1 and -1?
No, because that's quadrant where it can be positive plus 3.
Oh, on this I will point out, sometimes on log cosines, when you crunch this whole big fraction, you will get negative numbers, and that's okay, because if it's an obtuse angle, cosine's negative in the second quadrant. And if you put a negative on there, your calculator will kick you out a second quadrant answer because it knows inverse cosine is negative in the second quadrant. So it may kick you out 120 degrees. So it's okay if that decimal comes out negative, that's okay.
Is it possible that like with a no solution?
No, these will work. Yep, these will work. The only no solutions on that law of sines with the angle side sides. These always work. And remember, angle side side is the only one that wasn't a congruence theorem. And it doesn't then work for us here either. All these others were actual geometry theorems that were worked, and they give us correct solutions. That's the nice part of it.
Not any degree, or I mean any degree, but it was still good in there.
Just use law of sines.
Okay, I'm going to have to look at what you type. I'm guessing you just have a typo somewhere.
Use law of sines to figure out the other one.
Yeah, you really need to figure out what more. Oh, I know it does, but I can,
Oh, you just signed some cosine? Now then. That's plenty of room.
there we go.
Yeah, well, I can stop it because